Livestream actually works, I got it to work. After calling my baby brother, he was able to walk me through live streaming. I had no idea you had to download all these different things. The first program I downloaded didn't work. Could not figure out how to, so definitely don't ever download Air Server. But the OSB program definitely does work. So this is just going to be a short, sweet review to make sure that you are understanding everything you need to know for the test tomorrow. I know we studied today in class and went over a review today and hit a lot of topics on Wednesday as well. But anything I say in this video you still don't understand, that is where you probably need to go study. That is what you need to study. So I have a list of things and topics I want to cover, and I want to be able to go through. So please make sure that you have the different ionization energy, the electronegativity, the ionic radius sheet, and the atomic radii. The sheets that we did in class this past week. Again, I will be uploading those to eClass, so those will be able, after this video, to be on eClass for you to use to study with. So let's talk about electronegativity real quick. So I'm going to bring it up. So you notice that electronegativity, it decreases going downward and increases going across. That the highest element with electronegativity is going to be fluorine. The element with the least electronegativity is going to be frankincense. Now, remember that electronegativity is the ability to attract electrons. So keep that in mind. Remember that the ionic ionization energy, the first energy, ionization energy, looks exactly the same as your electronegativity. That going down the different periods, so remember that periods are across, groups are going down. So when you go down your groups, for your electronegativity and your ionization energy, your first ionization. Then as you go across your periods, it increases. So try to keep that in mind. Then for your atomic radii, it increases going down and it decreases as it goes across. So it is the opposite of your ionization energy and your electronegativity. So please keep that in mind. All right. In class, we are able to discuss the differences with nonmetal, metal, and metalloids, the categories that all elements fit into one of those three categories. Metalloids and nonmetals are also family group names. If you have not gotten to know your family groups, look at your chart, or if you didn't complete one, pull up an adorable periodic table such as this and make sure that you know each of your family groups. So over here in the orange, for your S1 orbitals, right here, all of your S1 is your alkaline metals. Next are your alkaline earth metals. And this is your S2 groups. Then right here in the middle, this beautiful little funky light green color is your transition metals. Your yellows are your other metals. Your bright greens in the middle are your metalloid family group. Then the purple is your nonmetals. The fuchsia pink color here are halogens. And then your light baby blues here are your noble gases. Down here, the rare earth metals. Please remember about your S, D, P, and F orbital shapes. That right here is your S blocks, also including helium. Then in the center here is your D blocks. Over here to the right of the screen is your P blocks, and at the very bottom, your rare earth metals, right here, are your F blocks. So, if you ever get a question that asks you how many electrons are in each of these different shapes or blocks, just remember to count your elements. So each S block, so this is your 2S blocks, has 1, 2. So this is 2S1, 2S2. Then your P blocks always start with 2P. So up top, the hydrogen and helium is your 1S1, then helium being your 1S2. P starts with 2P, so boron starts the 2P groups, so that's 2P1, carbon's 2P2, nitrogen's 2P3, all the way, and neon ends it with 2P6. Then your D blocks start with 3. So SC is your 3D1. Zinc ends it with 3D10. So remember, you can write on the periodic table tomorrow. So S1, 1S, 2P, then 3P. And then you just go straight down, meaning that if this is your 1S, this would be your 2S, this would be your 3S, 4S, 5S, 6S, 7S. Over here with your P's, it's 2P, 3P, 4P, 5P, 6P, and then we don't do 7P. F would be, not F, 3D here, going down to 4D on the next row, right here, then 5D, and then 6D. So your first rare earth metal is a 4F, 5F underneath it. All right. The reason why I've been expressing electron configuration is that in some of the questions tomorrow, you're going to see a noble gas configuration or an electron configuration, and asking you to, 1, figure out what element it is, but 2, if that element is in a particular family group, if that element is in a particular category like metal, metalloid, non-metal. So make sure to use some of the tricks on counting the different numbers that are in the power spots, if it's a full electron configuration, or using your periodic table to figure out what element it is. All right. All right. On the periodic table, the numbers down the side here are your periods. Please remember that each of those periods also means that it is their number of energy level. So you can identify any of the elements' energy level by just seeing what period it is in. Also, up top, using your groups, you can identify how many valence electrons are in that particular group. So, real simple. Group 1 has 1 valence electron. Group 2 has 2 valence electrons. Then group 13 has 3. Group 14 has 4 valence electrons. Group 15 has 5 valence electrons. Group 16 has 6 valence electrons. Group 17 has 7 valence electrons. Group 18 has 8 valence electrons. Remember, noble gases, because they have a full 8 electrons, a full valence electrons, they don't like to play with others. They're non-reactive. So remember that the rest of the elements and all the other groups, due to the octet rule, where the octet rule states that elements will either lose an electron or gain electrons to form that 8 valence electron ring and stabilize. It's all about those valence electrons. So, when elements lose an electron, so example, lithium. Lithium has 1 valence electron. It is easier to lose 1 electron than to gain 7. So, up to this point, lithium has an equal number of protons and an equal number of electrons. But if lithium wants to bond with someone, he's going to give away one of his electrons. I think this hand was electrons. Electrons. So they go from being even to the electrons being lower. So remember that protons are positive, electrons are negative. When they're equal number, they cancel out, and you have the same number, same charge, nothing's going on. But when he gives that electron away, he no longer has the same number. So there are more positives than negatives. That is why his ionic charge, his oxidation number, is a positive 1. Same thing for group 2. He becomes a ionic charge or oxidation number of a positive 2, because this whole row with 2 valence electrons, so like magnesium has 2 valence electrons, he's willing to give up 2 of his negative electrons so he can bond and make friends. All right, so jumping over here to group 13. Group 13 has a +3 positive ionic charge. Group 14, because it has 4 valence electrons, so it can go either way. Depending on who group 14 bonds with will depend on if they gain 4 other electrons from someone else, or if they give away their 4 valence electrons. So that's why he's a plus or minus 4. Then for group 15, he's a negative 3 valence electron. Not valence electrons, ionic charge. 3 valence, negative valence electrons. Then for group 16, he's a negative 2 ionic charge. That's his oxidation number as well. Group 17 has 1 negative 1 ionic charge. Now, try to remember, why does halogen not have any ionic charges? Pause. I don't think you can pause live feeds, but anyhow, noble gases, at the end have a full 8 valence electrons. So he does not need to gain or lose any. So he is non-reactive and he has no ionic charge. All right. Please know that where your nonmetals are, your metalloids and your metal categories. So on the periodic table, everything right here are metals. This thick line dividing, that's where your metalloids are. Then carbon, nitrogen, phosphorus, potassium, oxygen, chlorine, fluorine, bromine, silicon, iodine, fluorine. And going into your noble gases are your non-metals. So remember where they are, the categories on your periodic table, and that the metals have more elements than metalloids or nonmetals. All right. I cannot express to you enough how much you need to know all of your groups and how you can identify them. So please, please, please know that the purple here, your nonmetals, and your halogen and your noble gases are all nonmetals. Metalloids are the green here. Then your sunset colors of orange, which are your alkali metals. The light orange, your alkaline earth metals. And this funky green color, your transition metals, those are all metals. So please, please know them. All right. Be able to identify where the ionic charges are, at the top of the page, also known as your oxidation numbers. Remember that group 1 is a positive 1. Know that all positive ions are cations. Also, all negative ions are anions. All right. If you guys are still confused, message me. Hopefully this helped as a crash course tonight. Hopefully you're feeling better about being prepared tomorrow versus freaking out of, oh my goodness, I don't remember this. Electron configuration, I'll do a video here in a second, but I was going to divide them up so that way there's not too much live streaming in one video. Again, please message me if you have any questions, and I hope you guys have a great night. and I'm really glad I figured out how to do this. Bye.